Hello everyone. Today we are going to discuss two very important topics in data science and machine learning. First is exploratory data analysis, EDA in short, and feature engineering. My name is Sumudhu Tenakon. I'm a data scientist. I'll be helping you out through these lessons to navigate your data science and AI career. In our previous sessions, we discussed in brief about AI, data science, and machine learning, how they are related to each other, and also I gave you some examples to give you a basic understanding of how AI and machine learning work with data. And then we explored like some of the practical applications of machine learning. Then we discuss your basic mathematics and statistics foundation knowledge you need to have in order to succeed in machine learning and data science career. If you are a beginner coming into this area, so what mathematics and statistics knowledge you should have. So that we discuss, and then the necessary programming knowledge and understanding we discuss related to Python. So we explored several Python libraries. NumPy as the library you can do numerical and scientific computing, and Pandas is the library you can do like data frame. You can do several data manipulation tasks using data frame concept using pandas, and then matplotlib and seaborn libraries as the data visualization tools you can use in Python. And lastly, we discuss how you can build machine learning model using scikit-learn library. It's a very powerful library available in Python. So then we went through like a couple of examples. One is building a classification model and building a regression model. So those are the things we covered so far. And if start discussing our topic today, so let's see in general what are the steps of building machine learning model. We discussed this before as well, but I wanted to give you now like a little bit of detailed picture because now you are moving forward with your machine learning lessons. So the machine learning model building starts with acquiring data. You need to get data from somewhere, and then you are doing data analysis work, and you are preparing your data which should be ready for your machine learning model building task. And while you are preparing, you are getting to know more about the data. That is what we are doing in terms of exploratory data analysis, right? So like I said, previous lessons, during this machine learning model building or data analysis task, what you are doing is you are essentially having a conversation with your data, like you're having a conversation with another person, right? So you need to talk to data, you need to understand it better, you need to have some back and forth conversation going on. So how you can do is you have to apply certain techniques to ask some questions, some relevant questions from the data, and data is not live, so you have to use some techniques to retrieve your answers as well. So exploratory data analysis will help you in that. And after you did your data like exploratory task, and if you get know more about your data, you know the data well, so then you can move forward with your feature engineering, which is essentially you are preparing variables for your machine learning model building. And then you move forward with the next steps. I'm not going to go into detail, but in very brief, so you will be building the machine learning model, which is like training your model using the variables you created in feature engineering. And then you are going to evaluate the model, and you are doing like predictions on your test sample, and then do the evaluation, and then you are tuning the model to make your model perform better. So these things we will be explore step by step how you can do that, and what are the practical with the practical examples, right? After you do all of these tasks, you're going to deploy your model into your production environment, which is essentially embedding into application or serving uh, like to your user via another application platform, right? So your task will not be end at that point. So you have to continuously monitor. So you have to have some other form of monitoring your model, how it perform, if there's any problem. So you need to attend, and probably the cycle is not like a waterfall like cycle. So even you see in the screen like that, so everything is connected. Maybe during the monitoring, you will find some issues, and you need to go back to a data acquisition step, and then again go through the cycle, or maybe you can do some fine tuning depending on the issue you are encountering. So you need to go to a previous step and go through a cycle. So the machine learning model life cycle, I can call it, is a closed cycle. Even you see it's like open ends, but you will be going through multiple iterations to make your model perform better, or your model serve better in your application. Okay, so now you know like where we are at, and what is this exploratory data analysis, and where at which step it will be helping. So it is not only helping in this data analysis and data preparation step, it can also help in the data acquiring step, because we wanted to make sure like whether we get the correct data. Probably some of the exploratory data analysis tasks you should do during the data acquisition phase. Some of the data explore EDA tasks probably you have to do while you are monitoring, right? So sometimes you can do like when you are evaluating the model, depending on the need, you probably need to apply the same technique, right? uh, in different data analysis tasks. Okay, so before we discuss exploratory data analysis or EDA, so let's try to understand about the data. I mentioned multiple times the machine learning cannot survive without data. So data is the essential part of your machine learning model building process, right? Therefore, you have to have like a better understanding what data you are accessing. So you wanted to know like in detail what type of data you're accessing. Therefore, I wanted to take the example of a person. We can model like a person by their characteristics, right? So characteristics can use to describe that person. For example, name, age of age, date of birth, gender, hair color, eye color, right? And the location he or she lives, right? Phone number, like such as like contact information, maybe a picture of that person, identification number, like the profession he or she is involved with, right? The education level, and some other quantifiable characteristics like weight, height, and the salary he or she earn. And then like many things you can use to describe that person, right? Thus we call features or attributes. So in machine learning, those are like very important for us to handle while we are preparing the data, because those are the essential things will be feed into your machine learning model. So we will discuss the different types of features and how they are used in machine learning model. But this picture I wanted to get the idea about what is attribute, what is features, and the features and attributes, we will use these two words to describe the same thing. Depending on the source you are referring to, you will be hearing these two things. All right, now let's try to understand like what is the tabular data means. So we all know table, and we all work with like a tabular data at least once in our life. The table consists of rows and columns. Horizontally you have rows, vertically you have columns. Each column can have a name. A row can have a like ID or not. So we can say row 1, row 2 through 3, right? The column also you can name as column 1, column 2, column 3 if you don't have a column name. In a tabular data, a row we can identify as a record. So in this case, if you are thinking of like people data, or like data about like multiple people, so a row consists of like data about a person. For example, in this case, we have 3 columns: ID column, name column, and date of birth. And for a single person, we have like ID, name, and date of birth in three cells in that row. So a column in your data set, or like a tabular data or table, represent a field. So we call like a data field. So these things you will hear again, like those two terms, or the data field and record. So if you are referring to a tabular data, you can think of row is a record and column is a data field. Next, we are going to discuss very important concept about the data, which is qualitative and quantitative nature of data. So data can come in many forms. Data can come as qualitative data or quantitative data. As the name suggests, the qualitative means you are describing some quality about something. color of a flower, right? So it's a quality. Smell of a flower, that's also a quality. And as the name suggests, in the quantitative means you can quantify, you can measure, you can give a number to it, right? So let's first look at what are the qualitative data. So we also recognize them as categorical data. Qualitative or categorical data can have like three different forms. One is nominal, which is no inherent order or ranking. For example, like color, gender, country. Color, you cannot say blue is greater than red, red is greater than green. You cannot have a rank or order, right? So gender and country are the same. In an ordinal variable or ordinal data field, values can have an order. So values like such as a grade in your exam. So if you paste into exam, you will get a grade A, B, C, D. So A is greater than B, we know that. B is greater than C, right? So it has an order. So performance, if you get a rank, so rank 1, 2, 3 from like a performance ranking, so we know rank number 1 is better than rank number 2, right? In Olympic medals, so you know gold medal is better than a silver medal, right? So we have a ranking. So ordinal, it always rank your variable, and you'll know by the value which one is higher, which one is lower. Binary you can take as a subset of ordinal and nominal depending on the use. So but binary is a special case. So binary can have only two options. So one is accept, reject, if you are accepting or rejecting a loan application. So you can have two choices, right? You cannot have in between. If you say something, if someone asks you a question, a yes, no question, yes or no. So you can have like either yes, either no, pass or fail. If you have only two choices, if you must take one of them, so that those are the binary variables. So we looked at qualitative variables. Next, we can look at quantitative variables. As you see here, like the quantitative variable, we are also calling numerical variables. And numerical variables can be in two categories, discrete or continuous. So in discrete, the value can be expressed as whole numbers, or it could be like discrete values. For example, pages in a book, you can have like page 1, page 2, page 3, or you can say this book has 42 pages. You cannot have 42.5 pages. Someone can tear the page into half, but still the page number is 42, right? So like that, you cannot have a value in between. So for example, invoice count. So if you are working in a business, or if you're having a business, you are receiving invoices, you can have like 2 invoices, 3 invoices per day, but you cannot have 2.5 invoice today, right? So those are the discrete variables. Another example is wheels in a vehicle. You can have 3-wheel vehicle, 4-wheel vehicle, 2-wheel vehicle, but you cannot have 2.5-wheel vehicle. So in the continuous variables or continuous data fields, we can get measured on a continuous scale. So means you can have a value in between two values. For example, weight. So when you go to a grocery store, you buy an apple or like banana or like a fruit. So you always need to measure. Like you can also get the quantity, like 1, 2, 3 apples, like 1 apple, 2 apple, 3 apple. As also you can measure it. So if you measure weight can take like 1 kilogram, 2 kilograms. Same as that, you can get 1.5, 1.52 kilograms, right? 2.2 kilograms. So always you can get a value in between. That's why we call it the continuum scale. So if you take two values, it can be subdivided into fractions. So you can have like 2.35, 2.355. So anything like weight, length, time. So you can always subdivide it into intervals, and then you can get in the fractional values, right? So the continuous variables and discrete both are considered as numerical variable, which are quantitative in nature. And the qualitative we discussed earlier, which we use to describe a quality of something. Those could be in order or without order, right? So having a clear picture of what data you are accessing will be very helpful in exploratory data analysis, because some techniques you have to apply for numerical variables, some techniques you have to apply for qualitative variables. That is why I wanted to have this slide before we are discussing those techniques, or before we discussing anything about the EDA work. So you have to have the clear picture. So this is like a very important concept you have to digest and you have to understand it better. So okay, let's go to our next topic. Let's try to understand quantitative and qualitative nature of data with an example. So in this example, you have tabular data set. You have like 4 records from like collected data for about age, weight, and height from 4 different people. And so let's try to understand which category each data field belongs to, right? The first column is an ID column, so we don't need to consider that as data is relevant for your machine learning model or any analysis purpose, but it will be used to identify each row. It's a unique identifier to identify each row. The second column, gender. So the gender is a categorical field, as you see here, but at least in this column, at least within these 4 values, you can see only 2 different values. So those are only 2 options you can take, either male or female. So this will fall under qualitative variable or qualitative data field, and also a binary data field, right? Because at least in this 4, you have only 2 options. The next, age. Age, we see like a value 2, 4, 5, 3. So in this data set, we have no definition of what age means. So age is measured in years, I assume, not in months. At least we can make an assumption. So and also another thing, we don't see any decimal points, but we have to assume the age is given as a number. So this is a debatable thing. We can either say this is still a continuous or discrete, but it is clearly a quantitative field. You can put it under discrete or continuous. The next field is weight. So weight, you see always we have the decimal points. We have 14.0, 18.6. So these are quantitative values, right? The weight is a quantitative field, then it should fall under continuous. Height, also the same. So you have decimal points, and we can put it under quantitative variable or quantitative data field, and it's also a continuous. So that's another important thing you should understand with the data. So when you get the data in computing, we always need to understand what data type it is. So let's look at it in our next slide. But before we are going to do that, so let's understand like in very high level what are the data types we see, at least in this slide. So we know male, female. So those are like represented by characters. So we know these are like strings. And age is a number, whole number. We don't have decimal points. These are integers, we know. And then the weight and height, they have decimal points. In computing, we call it like floating point numbers, right? So let's look at in detail what are the things we should know about the data types. So the data types is also very important to have that understanding. Data types can be divided into several categories: numeric, text, logical, other data types. So some programming languages, they create data types as objects, such as Python. So all data types in Python considered as object data type. That's a superclass. But you can have like a separate subclasses like numeric data types like integer, float, and complex numbers. Also, you can represent it by a separate data type depending on the programming language you use. And then the text data type. Text is represented by either single character or multiple characters. So multiple characters are called strings, single character, the character variable. But in like languages like Python, you don't have like a separate single character variable. Both single character and multiple characters we consider as string in Python. But some programming languages, you can define single character and variables as a different data type, and strings as a different data type, right? And the logical data types, either those are like we call Boolean. Boolean can take only 2 values, true or false. So it definitely is a binary variable that's we will be creating with the Boolean. That's obvious. And the other data types we can call files, images, videos, sounds, any other thing you store as a data type in that programming language defined to you. So you can consider as others. So this is kind of a hierarchy. So what we have in terms of data types in very high level, but depending on the programming language you use, you have like a proper definition of each data type. Right? This is for your general understanding. Few things I wanted to have like have a deep understanding on data and data analytics and machine learning, model building, or anything related to data science work. So you should know whether the data can exist or not for a specific data field. So we wanted to define what is the representation of nothing. If the data don't exist, what is the representation? Depending on the source you receive data, they could have like a different representation for nothing, right? Some people put negative 99 to say, okay, we don't have that relevant data. So if you find like in an age column, all of a sudden we have like a negative 99. So that means you have to first need to consult the person who sent you the data, or the any source you need to refer any documentation. What this negative 99 mean? It could be a simple error. It could be a meaningful thing to indicate we don't have a record of this person's age, right? But in Python, we use none to represent nothing. And SQL or SQL, we call nothing. We represent nothing by like a keyword called null. Some programming languages we use void. So we have to have some way. We have to have understanding depending on the programming language, depending on the platform we use. What is the representation of nothing? It's very important. Pay attention to that. Sometimes in some platforms, empty string could be a representation of nothing. Okay, so the other data representation, numeric data can be represented as vectors, matrices, and tensors. We discussed these things in detail with the mathematics concepts. And vectors, matrices, and tensors also can be fall under a data type depending on the programming language you use. And the collection could be sets, lists, tables, dictionaries. Could be we have like arrays in some programming languages, right? In Python we can create arrays or lists or sets, tables, dictionaries, different data structures to store your data. And the other structural representation, enumerators, structures, objects you can create. If you are using object-oriented programming language, Python, you can create objects. So you can also create. So they can fall under like a data type, or you can create your own data types for those. All right. So okay. So let's start our discussion on exploratory data analysis, or EDA. Here, like, we are going to discuss three topics: descriptive statistics, univariate analysis, and multivariate analysis. So we use descriptive statistics to get like a basic understanding of a variable. So basically in univariate analysis, we will be using a lot of descriptive statistics to know that variable better. So as the name suggests, univariate means like you are analyzing a single variable at a time. So we are using some descriptive statistics and other techniques to know better about that data field. In multivariate, we use some techniques to study two or more variables together to know how they are behaving. So in this foundational level understanding, so I will be discussing like a special case is like bivariate analysis. We are using two variables at a time, and we are trying to find out the relationship between them and get to know about their behavior together in our machine learning problem, or the problem we are trying to solve in these examples. Okay. So we will study some of the techniques and methods we can use in the univariate, multivariate analysis, and we will try to incorporate the descriptive statistic in this exploratory data analysis work. Let's get to know about univariate data analysis. As I mentioned earlier, the univariate data analysis uses single variable at a time. So the techniques we can use in univariate analysis is descriptive statistics, frequency tables, count plot or bar plot for a categorical variable. For a numerical variable, we can use histogram. Both the bar plot and histogram will give you an understanding of the data distribution in your dataset, same as the frequency table, and also descriptive statistics. So we will give you a quantifiable numbers about your distribution. And the box plot will give you also the data distribution, as well as it will be helpful for you to understand outliers. So we will get to know about these things in the coming slides. Just hang on. Let's look at descriptive statistics. What are the things where we can track? Range, median, mean, mode, variance, standard deviation, coefficient of variation, covariance, correlation coefficient. Those are the descriptive statistics concepts. Some of the things you can see like there's a univariate analysis and the covariance, correlation, coefficient. Those are you can use for bivariate type analysis. So we will get to know each and every of these. Data distribution is very important thing to analyze when you get a data set. For example, in this case, we analyzed an annual salary column from an employee data set. So distributions can give you very important features. So one is like an idea of the central value and the spread. So how the data is spread, how is it a narrow spread or wide spread you can get. So we can visualize this using visual techniques, as well as we can use some descriptive statistics method to get a quantifiable values to know what is the central value and what is the spread. And the three diagrams you see here, the first one, the top one, will have like a distribution with indicated by the central value and the spread, and you have the red curve is the distribution. And x-axis of this is plot tells you the annual salary, and y-axis value the employee count for each salary value. And the second, in the middle diagram, you see the central value of this distribution. Focus on the central value and the spread in these three diagrams. Central value shifted towards the right side, which is the higher salary side, but the spread stays the same. In the third diagram, the spread is narrower, but central value keeps the same. This is like how you can understand what happened to your data. Maybe with the time you will see these differences in the distribution by different sample to sample. We discuss about the samples. So when we are discussing about statistics, you will see the distribution is going to be different. So we need to address these things. Therefore, I highly suggest you can use the like a visual technique or like a descriptive statistics method to analyze this data distributions if you're continuing with your machine learning model, if you're using this data for a machine learning model. Let's try to understand these terms in descriptive statistics. First, the range. Assume you are given a data set of 1,000 people. So you have the age column there. So in this age column, you have a minimum age is 50 and maximum age is 85. So what is the difference between maximum and minimum is 70. So the difference between max value and min value will give you the range, which is 70 in our example. So now you are ordering your age values of like 1,000 people from lowest to highest. Then you want to take the middle value, let's say 500 value, right? So that value will be your median. And if you wanted to take the average or mean value, what you will do is you will sum all the ages of the 1,000 people and divide by 1,000. That will give you the simple mean. There are other ways to calculate mean, weighted mean. So if you wanted to give a higher weight for specific values and lower weight for specific values, depending on your application need, so you can get the weighted mean. Geometric mean also you can be used depending on your use case. And the mode will tell you the value that occur most often. Let's assume you got like 300 of your 300 rows in your dataset has the value age is 37, but all other age values will have less than count 300. So that means 37 is your mode. One key thing to note about median and mean. So remember the data distribution we discussed earlier. So when we are discussing about the central value, if assume now you have age column, you have about age from 1,000 people, all in sudden because due to a data error or for any reason you have like a person age is 120 and you have like maybe two of them, so it will make your value shifted towards the high and the mean value, right? Because you are adding the very high values into your sum and then divide by the total amount. So if you have an outlier, so 120 may not be an outlier, but if you think of like by any so you are measuring something and you are normally will get a value between 0 and 100, but for some reason you get a value 5,000. that is really an outlier. So if you take mean value of the 1000 item, and usually you get the value between 0 and 100, but you have a single value of 5000. So when you add that 5000 to calculate your mean value will be highly influenced by that outlier, right? But now let's assume the same thing. You have the same outlier, but if you order your data set from lowest to highest and you take the middle value, will it change the middle value, presence of that outlier? No, because the presence of the outlier will not influence your median value, because the middle value is always the same. It's no matter whether your higher end or lower end is having a very high or very low value. So median is not influenced by the presence of outlier. So this is like a very key important thing is to understand about median and mean. Look at variance, standard deviation, and coefficient of variance. First, variance. So variance will tell you how data spread across mean. So the variance will tell you like the spread. Remember our the previous example, the data distribution. And the standard deviation will be the square root of variance. So you will see sigma squared is the variance, the notation for variance, and sigma is the standard deviation. And the coefficient of variance is known as the standard deviation divided by the mean value. So you will see like two different like terms we calculate, one for population and one for sample, and we discuss what is population and what is sample in our statistics lessons. So we can so slight differences of calculating standard deviation and variance for sample this population. So you can look at it. I'm not going to go to a very detailed discussion, but like in simple terms, what you need to know is variance and standard deviation will give you an idea of the data spread. Let's look at histogram as a tool. You can perform univariate analysis on numeric columns. So histograms will allow you to approximately represent the distribution of numeric data. So what the histogram does is the numeric scale divided into range we call bins, and x-axis of the histogram is like we have the bin edges, and y-axis represent how many like item counts in each bin. We will get to know more detail about how we can generate histograms in Python, but like this, the basic understanding of what is histogram will be given here. Frequency distribution tables. Assume you have like a product, you are analyzing like a product line in a factory. So you wanted to have like a count of product coming from the your production line, and maybe it's coming like as different colors, so we want to know how many counts, right? So red, blue, green, yellow are the expected colors. Assume like you are working on a factory producing t-shirts. So each entry in the frequency table is contains the frequency or count of the occurrence of the values within a particular group or interval. So here is a group, like group by color. We have red t-shirts, 7 red t-shirts, 4 blue t-shirts, 5 green t-shirts, and yellow green t-shirts. Frequency tables are good for categorical variables. If you have a continuous variable or a numerical variable, you can still convert that numerical variable into bins, same as you did do in histogram. You can have a range, age between 0 and 20, 20 and 30, 30 and 40. You can create categories, and then you can create this frequency distribution table. These are like very powerful tools, simple but powerful tool we are discussing to do this data analysis work and help you to build better machine learning models. If you know data better, you will build better models. So the categorical values with lower counts can be combined. Means like if you have, I don't have this example in the slide, but if say like you have another color with say a dark blue, so only one t-shirt. So what you can do is, since blue and dark blue have some relation, you can combine dark blue and blue together and create like into absorb into blue and make it a 5. right? So categories with lower counts, we usually combine into one category. Sometimes if you have like, multiple categories, say like we have 10 different categories, but we want to minimize number of categories, we need to find some relation and to try to, condense your, 10 categories into maybe 5 categories. We have to apply a certain domain understanding and some other understanding of what the data you are studying in order to do that, right? So let's look at like another representation of your frequency table. So we can create bar charts using your frequency table. So each bar in this bar chart, let's focus on the left side first, represent the same information in the frequency table. Each bar, the length of the bar will represent what the count, right? And each bar represent a color or category. A bar chart, bar graph is, or bar chart represent a categorical data with the rectangular bars with height and or length. So some bar charts you can create as columns, like as you have seen in the right. So we call it a column chart. So that in that case, height will represent counts. In a horizontal bar chart, the regular one, you can say the length represent the count. Okay. So let's discuss another one, Pareto chart. So yeah, so this is another variation of bar chart combined with a line chart. So in this chart, a bar graph are like individual values. Remember what I have in underlined in descending order. So you have to create your bar graph. Your each category should be in descending order by its count. And then the line graph will show you the cumulative total. So cumulative total is you add a count of the first category into second category, then you have the second data point, and the first and second category add into the third category count is the third data point, like that, right? So that's your cumulative total. So the bar graph and line graph together, this is also be like a very helpful tool for descriptive statistics if you want to create a report and to make some decisions, either business decision or decision about machine learning models. So this will be a useful tool. Oxford is a very powerful tool in data analysis work, not only to find outliers or presence of outliers, but also to know very important details about the data distribution. Before we are discussing box plot, let's try to understand what is quartile and percentiles in this slide, because those terms are very important to understand what is box plot. Remember, like when we are discussing about the median, so what I mentioned, like you have like age column, 1,000 people, you arrange that age column into like lowest value to highest value, right? So the first 250 out of that 1,000 rows will be your first quartile, because you are dividing your data set into 4 parts. Quartile is 1/4. Second quartile is from 250th item to 500th item, and then 500 to 750th item will be your third quartile, and 750 to 1000 will be your fourth quartile, right? I hope that is clear. And we also can consider as the first quartile is 25th percentile, because percentile is 1 or 100. So you can have 1 percentile, 5th percentile, 10th percentile, like that. Okay. So you know what is now first quartile and third quartile. So the difference between first quartile and third quartile we call interquartile range. So we call it IQR here. Right? In the box plot, it, as the name suggests, it's a box drawn between first quartile and third quartile. Right? That's the width of the box, and the median value, which is your second quartile, will be represented by a line. And the whiskers, we call those are like whiskers, which will tell you the boundaries of your data set before outliers. So these values will be determined by the third quartile plus 1.5 times interquartile range will be your positive boundary, and the negative side will be first quartile minus 1.5 times interquartile range, right? So anything below and above these whiskers will be considered as outliers in this box plot. Right? We will get to know how we actually see this in Python. So this will be very helpful for you to know whether your dataset or this column you are analyzing contain outliers, right? And also to know this the quartiles and the distribution. Okay, so let's move forward. Now let's look at bivariate analysis. As the name suggests, like bivariate analysis, we use two variables at a time. The techniques we can use are like cross tables, or we can call crossway tables, or contingency tables we can call, and scatter plots. You all know scatter plots, and correlation coefficients, stack plot, heat maps, pair plot, marginal probability, conditional probability. We discussed those things with the probability statistics and probability lessons, and regression. As a bivariate analysis technique, covariance and correlation coefficient will be very important to understand. First, the covariance. It checks whether two variables are moving together or not. So if the covariance value is greater than 0, that means two variables are moving together. If variable value is less than covariance value is less than 0, variables are moving into opposite direction. If the value is 0, that means those two variables are independent. In machine learning, this concept is very important, because if two variables are moving together, that means the one variable has a relationship with the other variable. So probably we can use this for to get some meaningful insight. If two variables have nothing to do with each other, maybe like whether we should use this variable depending on the use of that variable in your model building. If it is the variable you want to predict versus the other one will be your feature. If they are not having no relation, probably that is not a useful feature to use. So we will get to know about these things in detail when we are discussing about the feature selection, how you can use correlation and covariance to identify features you should use and features you can remove. The correlation coefficient is simply like correlation divided by the sample standard deviation. The correlation coefficient value should be always between -1 and +1. If the correlation coefficient is +1 or -1, so that means we are having a perfect correlation. Means like if you both variables moving in a line, if you plot in a scatter plot. If the value is in between, you will have like you have some spread in the data points in your scatter plot. If the correlation coefficient is negative, right? So then that indicates like it's a negative correlation, which is your two variables are moving into opposite direction, and it's a positive. If the correlation coefficient is positive, we call it a positive correlation. If the correlation coefficient is negative, we call like two variables are independent. You can see in the right side, so three diagrams. You will see the first one is having a negative correlation. So when x increase, y decrease. And the second one, you will see when x increase, y decrease, we don't have any relationship between x and y, right? So we call like the correlation coefficient is 0. We can think of like the values are randomly scattered. And the third one, when x increase, y also increase. That is a positive correlation. To give you some idea about correlation and causation. Sometimes we fall into wrong conclusion without having a proper understanding of correlation and causation. Assuming this example, there's a hot weather created during this time, and then people try to buy ice cream. That could be a causation, because the hot weather, people wanted to get cooler, and then probably they wanted to buy ice cream and get cool. And then the hot weather can also create some problems in people, like people can get sunburn, right? When they exposed to hot weather or sun. So if we make a conclusion, eating ice cream can create sunburn, or the other way, the sunburn can make people buy ice cream. Can we make a relation? It could be related, two events are related, but that is not a causation. Yes, we can make a relation, but either sunburn will cause people to buy ice cream, this will not happen, and or the buying ice cream or eating ice cream will create sunburn, that will not happen as well. That is simply a correlation. It's not a causation, right? When you make a conclusion, make sure you understand this, and there are plenty of examples. You can read more about this causation correlation, but in our machine learning applications, we also need to understand the difference between causation and correlation. Okay, let's look at our next technique, which is cross table. You all know what is cross table. You use the cross table at least once in your life, So in the cross table, as you see here, consists of rows and columns. You can think of like a matrix, right? With the label matrix, it is basically like a table, tabular data. We looked at the tabular data before. In Python or in computer, we can implement it as a 2D array. So it shows the relationship between rows and columns. So for example, the columns will represent age group, rows will represent the education level. And this simple relation will tell you like the counts. So people with age less than 20 in high school is 1795, right? So you see that here. So this also known as contingency table. And when we use this cross table with other aggregate functions, here you have like simple count. We can take value like sum of another variable in place of the count, right? So average, mean, max. So we can use other aggregate functions. So then we can create pivot table. So in Excel or Python or SQL, you can create cross tables as pivot tables to get a very powerful technique. You can summarize data. You can create more insights out of your large data sets, right? Therefore, the cross table is very useful tool. We will get to know how we can create cross tables in Python using pandas library and get use of it. Let's look at the scatter plot. So when we want to analyze two variables together, like we already saw, like how the correlation and correlation coefficient and covariance, how we can analyze, and in the scatter plot example I showed in that slide. So that's a scatter plot. So the scatter plot can be either 2-dimension or 3-dimension. So each marker in the scatter plot represent a data point, and the location of that data point determined by the value of like x variable and value of y variable, the intersection point of x value and y value, right? If it is like a 3-dimensional scatter plot, you have the z-axis. So you have to get the intersection in the z-axis as well. So basically, the scatter plot we can use to visualize the relationship between two variables. It's very useful technique if you can draw the scatter plot, and if you have a regression curve or like a data the linear fit, you can easily try to linear or any other curve fit technique you can apply, and you can plot in the same diagram, and you can see whether how your plot against your data point. This is a very powerful technique. Then the heat maps. The heat maps also like a technique people use to represent like 3-dimensional data in 2 dimensions. And also this will be a very useful technique to visualize a pivot table or to visualize a cross table, right? This will be easy if you I mean, people can easily read numbers, but when it comes to understanding, so if you have like if you have visual representation, so if the numbers represented by color intensity or different colors, so we can easily see patterns, right? So therefore, heat maps will be a very useful technique to use in some situation when you are communicating with a group about your findings from your data, etc. Right. So the XY grid is defined using two variables you have to choose. So in this case, age group and hours per week. So those are two groups. So each cell in this grid or each grid point we can test cell as a grid point it will be a category defined by these two variables, right? And the third variable will be the intensity represented by the intensity. So that is the number of count, like the people count belongs to each category, right? So if you have, for example, the bottom left corner, the cell in the bottom left corner will tell you people with the age less than 25 as well as they work hours greater than 60 hours, right? So that's the category. And the top left category will tell you the people with age greater than 25 and they also work less than 25 hours per week. Like that you can read the cells in the heat map. And the most important part is the scale. In the rightmost side of this plot you will have a scale between like we have tick marks from 1000 to 8000, but in the actual scale go beyond below and beyond those two values. So that scale will tell you what is the number of people count in each cell, right? So this will be a very useful technique for you to get like nice visuals if you wanted to analyze or present, or if for you also to identify patterns before you attempting to with the feature engineering or building machine learning models. Here is another very useful tool called pair plot. In the pair plot, a grid is like designed in a way you can show a relationship between two variables at a time, but you can have like this relationship for multiple variables. In the diagonal of the pair plot, the plots in the diagonal, you can call it like tiles. So diagonal tiles in this pair plot will be the distribution, because the relationship between the variable itself, we don't have any meaningful relation in terms of a scatter plot. Therefore, we use that for the data distribution, right? And then the off diagonal elements are all as scatter plots, will tell you the relationship between, give you a picture of the relationship between two variables. This will be a useful technique. I think it's not a good idea if you have like 20 different variables against 20 different variables to plot everything in one slide and put into a screen or print to a report. So, but if you have like fewer variables, in this example, 4 variables at a time, so it's a good tool for you to use. All right. So now we discuss about the techniques we can use to analyze the data using univariate and bivariate techniques. So now let's look at some techniques we can use for data pre-processing. So in the data pre-processing, we have to deal with many things. So one is like treating missing values, because data always not come ready for our modeling needs or our data analytics needs. So we have to deal with some data issues. So one common issue is having missing values, right? It could be simply data is not collected for those records, or maybe like while converting from one data source to another or transmitting from one location to another, maybe could be as simple as the data entry errors, right? So never detected, and therefore the value is left missing. So we have to treat them. So we will get to know how we can treat them. And treat outliers. We learn about like the presence of outliers we can detect using box plot, right? So the outliers, I gave some examples. One example actually for a value, like if you have a value between 0 and 100, all of a sudden you have a value of 5000 in that column. So that value is an outlier. So how we can deal with these outliers is also we need to know. And scaling variables, sometimes we have like multiple variables in different scales. So one variable could be scale between 0 and 100, another variable between 0 and 1000, another variable can be 1 million to 2 million, right? So the range, so that's why the descriptive statistics is very important for us to understand the nature of your data set, right? So what are the ranges. So if those scales are very different, for some machine learning algorithms, it will create problems. You probably need to take all of these variable values into one scale. So means you need to take everything maybe between 0 and 1, right? So there are techniques you can apply to scale a variable. So we will get to know about these. Then the dimensional reduction, I'm not going to go into very detailed discussion, but I will briefly introduce. So it's simply what it does is it will reduce number of dimensions into lower dimensions. If you have like higher dimensions like 5, 6, 7 dimensions, so probably it's okay for some machine learning model. But if unnecessary to having like higher dimensions means how many variables you can use, you can reduce that. You can transform some variables into lower number of variables. It will be better for your machine learning model training, and also the other analysis you will be performing. So dimensional reduction we sometimes need to do. And the feature engineering and feature selection, so we can call like feature selection is a part of feature engineering as well. So this will be like a technique you can use. It can be used in the feature engineering. It can be used to create new features, modify existing features, transforming them, and deriving new features out of your data set, which you never had in the original data set, right? But you can apply certain techniques to derive that. The feature selection is something like you can decide whether I should use this feature for my analysis or model building, or I should throw it away. But you cannot just throw away just whether you like or not. No, you have to do it systematically. We will get to know how to do that. First, let's look at how we can treat missing values. So, the presence of missing values create issues, and also like I mentioned at the very beginning of this lesson, how you can understand the presence of like nothingness, right? So the missing value should be represented as nothing. You cannot have like 0 as for missing age. So if you in your age column you have one person don't have age, you cannot simply put 0 and get away with it, right? So you have to deal with it. So you have to either put none if you are using Python. If you are using SQL, you have to put null, or you have to deal with some other meaningful way. But in machine learning, we have to decide what to do with the missing values. Sometimes we can get away with rows with missing values. If you say like have a row with the missing value out of 1,000 rows, it's a very small fraction. So we can simply drop that row. If you have 500 rows with missing age, right? If the age column is very important for our analysis, probably we have to think of any other alternative solution we can take. But if there's no solution, we have to drop that, because with lot of missing values or without values, probably that column is having like less help to train your model. Sometimes such a column, can drop the entire column. You can keep the rows, but you can drop the entire column. So if you determine this column will not help you to build a better machine learning model, probably you can decide to drop. So that drop is one solution. Impute is another solution. In impute, what we can do is we can replace this value with another value. We can use some interpolation technique. For example, if you are having the weather data, so you know the temperature today and temperature day after tomorrow. Okay, bad example. So you know the temperature yesterday. You don't know the temperature yesterday. You know the temperature day before yesterday. Somehow your sensor didn't work yesterday. You didn't record the temperature, but you know the temperature today. So you can simply take the average between today and yesterday. That could be like not very meaningful, but you can apply some interpolation techniques like that. You can do a curve fit for the available data, and then approximate or estimate the missing the value you should get for the missing data point, right? You can apply descriptive statistics. You can replace missing values by like values such as median, mean, or mode, depending on your application. So the domain knowledge is going to play a big role in this impute technique, right? So you cannot simply apply replacing all and null or missing values by median as a recipe. You cannot do that. You have to incorporate a lot of domain understanding. And then you can use some machine learning model to predict missing values and replace by that value. So that would be a very rare situation, but sometimes if you really want to have that value, you need to have another model trained to predict missing values. If you are expecting missing value for ongoing project, if you are expecting that more frequent, probably training another model to predict the missing values will be useful. And you can also derive from the other columns like a gender. You can, if the gender is very essential, you can derive by the title. So if any columns will indicate whether Miss, Mrs, Mr, those things. But if you have something like a doctor, probably you cannot derive it very accurately, but at least you can get some values populated using the other columns, right? Or by the name. Sometimes name can be an indicator to know whether the male or female, if that value is not present in your data set. So if you cannot do anything, so it's a good idea to replace with a dummy value. If you really wanted to have a value, if you cannot leave it with null or none for any other operation reason, you have to replace with a dummy value. So you can, yeah, you can put an a or n dash a, whatever the one a value you want, you decided within your team or decided in your company, or this value should be put in all null values. So you should use that. The other method of like treating missing values is revisit. So you can, if you are the person collecting data, or if you're involved with data collection, or your team or company involved with data collection, you can revisit. You can go to the people who provided the data and ask them to provide the missing value. Or if you are consulting another company or someone, like you can ask them to revisit if that is a decision to be taken by analyzing the cost effectiveness of revisiting the data collection. Sometimes you need to spend a lot of money on to do that, so probably you will not get a chance to do that. Request is another thing. If you are getting data from another source, so you can ask the source to provide you with the missing information. Sometimes if it is a simple data entry error, maybe they will find original source and they will provide you the missing values. So request is another way you can treat the missing values. So now let's look at how we can treat outliers. So first we need to detect outliers to treat, right? So even for the missing values, we need to detect whether this column is having missing value or not. So we will get to know in how we can practically do that in our Python lesson. So the outliers also we need to detect. We know one technique, which is box plot. The other one is we can use percentiles. So we briefly discuss about quartiles and percentiles with the box plot. So we will get to have a detailed discussion with the Python lesson in another time. So how to remove outliers? So sometimes we need to decide whether we should drop rows with outliers. So if you are having a column with outliers, probably we will not drop a column because we are having outlier, because to have outlier you have to have like a very small fraction of your total number of values, right? So we probably drop the row with an outlier if we cannot impute that. So you can, like, we can impute as well. You can replace outlier value with another value. So if you wanted to say, okay, the minimum, so if there's an say something like a price, so we expect a price between 0 and 100. All in a sudden, like I'm coming to the same example, all in a sudden you see value 5,000. So the 5,000 you can replace by the maximum value of that that column. So 5,000 replaced by 100. That's the decision again you should take with domain understanding. So never take that decision by yourself if you are not a domain expert. If you are only the person, technical person building the machine learning model, always consult like a person with domain understanding before doing this. Before making these decisions when you are imputing. Okay, so that we call like a clipping that value. Another the technique you can use to convert into ranges, right? So you can say like, okay, 0 and 100, so we divided into ranges like 0 to 20, 20 to 40, 40 to 60, 60 to 80. Anything greater than 80 we will fall under the last category. So that means that include 100 as well as 5,000, right? So you can convert to ranges and you can get away with the outlier effect. But if this outlier presence due to an error or some other issue, you probably need to do like at least few more sanity checks or verifying whether this outlier is a real value or it's a data error. Right? Make sure you do that before you attempt any other. All right. So the dimensional reduction, like I said, so transform the data from high dimension into high dimension space to a lower dimension space, right? So for example, if you have like four columns, you have like four different variables. So you're creating like a 4 dimension. If you want to reduce that dimension into 3 dimension, your four columns or four data fields, you need to reduce into three. You cannot simply throw one column away or one data field away. You have to apply some techniques to combine those columns and make it like a 3 columns, right? So the dimensional reduction techniques help you to do that. So it retains characteristics of the original data, but your dimensions will be reduced. So it is useful for visualization, data visualization purpose, and observe patterns more clearly. And the principles you can use for dimensional reductions are principal component analysis, linear discriminant analysis, kernel PCA, and autoencode. So autoencode is a deep learning technique. If you want to read more, you can read along these topics. You will get to know like a lot of interesting videos in YouTube. Also, you can find out about these things. Okay, so now let's look at some techniques you can use for feature scaling. So like I said, you may have your different columns or different data fields in different scale. If you want to take them into same scale, for example, a value between 0 and 1, so you can use a normalization technique. So min max or like mean will be like two different methods you can use. Those are we call normalization. So we will get to know how we can do this in Python when we are discussing these normalization techniques, how we can apply for a practical application. And the standardization is also getting into same scale, but this scale is based on standard normal distribution. So we get to know about the standard normal distribution and how to calculate C-score or Z-score in our statistics lesson. So we can apply the conversion, calculating C-score for that way your variable or all your variables to standardize and get your variables into the same scale. Other scaling techniques are like you can use log transform, power transform. Uh, so depending on your application or depending on your in your domain, so you need to think of which transformation you need to use. Another note, like I mentioned about earlier, uh, for for uh, for regression models, this feature scaling is very important. For tree-based models, it's not necessary. You can still do that, but it's not necessary for tree-based models. Keep that in mind. So this is a standard normal distribution. We discussed this in with the statistics lesson, the key feature I need to highlight again in the standard normal distribution, standard deviation is 1, and mean, median, mode all are 0. So that makes you now know like your variable, no matter which scale you are in and what type of distribution you are having, if you take that into standard normal distribution, so your all variables will be standardized. Okay, so now we looked at like multiple techniques to do the feature scaling, right? So to transform your feature from one scale to another. So the encoding will also help you to transform variable. So if you have a numerical variable, if you wanted to convert into a categorical variable, you can do like we all discuss about the histogram like binning. So binning can be used for the first polar point numerical to categorical variable. So how we can convert categorical variable into a numerical variable for a machine learning application. So categorical variable eventually will be converted into numerical variables in modeling algorithm. But if we wanted to do that by ourselves, we can do that using several techniques. one is like one hot encoding method. So I'm going to draw and try to explain it better. So let's assume this gender column, right? So let's assume the gender column is binary. So you will have male and female only as the options, right? So I will try to draw it here. So you can have like a male, female, male, female, male. So those are the values. So in one hot encoding, we are trying to create two variables. One variable we call male, second variable we call female. So what does it mean by one hot encoding is only one value of those two variables created from this original column can be one. So one should be hot. Hot is one here, right? So if male is one, female should be zero. If female is one, male should be zero. Right? So for rows with the male value, you will see the male column will have one, the female column is zero. So you can observe the pattern, right? So this is how you can convert your gender column into one hot encoded variable. All right. So now you will see, okay, this is a binary column. So now we converted into two columns. So why we are having two different columns? Can it be like one column? Absolutely right. So you don't need to have like two columns to represent this gender column. You can have a column name. It's posing the question is male. Yes, is one. Zero is no is zero, right? So you don't need to have two columns now. You can represent by one column because this is a binary column. Okay. That is like a one hot encoding how you can get use of one hot encoding to convert your categorical variable, which is binary here, into a numerical column, like a binary value column. The other encoding scheme we can use called mean encoding. What we can do is instead of putting like 1 0, we can create the focus on the column with the red font. The gender mean encoded value is mean value of your male. So you say like in your data set 48% of your people in your data set are male and 52% is female. You can replace that value by the representative mean of each group, right? Even for any reason you have like 50-50, probably you need to be careful. Don't want to do that. So you need to have a checkpoint if you're automating this process, right? So in that case you have to use something like one hot encoding or this method. So if you have a a different mean, so you can always represent the value by the mean. So the other method is the target guided ordinal encoding. So you can not the mean value, but you can have like a rank, right? So you can give a rank 1 to the top value in the mean. So the female mean is higher than the male, so you can give 1 and 2. You can have that as well. So you can also have like label encoding as well as an ordinal method. So let's look at, so we look at a special case first, just to give you like understanding of one hot encoding and the mean encoding and target guided and ordinal encoding. So let's look at another variable. It's grade. So in your right side of this slide. So grade it's not a binary variable. So we expect A, B, C, D. So it has a rank, right? So it can take values like A, B, C, D values. And there's another problem here connected to what we just learned. So there's a missing value here as well. Right? So now we expect 4 different values, and we are trying to convert into a one hot encoded variable. So you will see like immediate problem. So why we don't have like a column named D? We have columns A, B, C, right? And the other. So we have we have 3 columns and the other column. So we don't have like a D presence here, right? We don't really need to have like D presence because you can think of like D as the other, but we really can we can represent A, B, C, D, all 4 values using these 3. If if the grade is taken like as the grade D, not A, should not be B, should not be C, all values should be 0, right? So in that case we know 0 0 0 means it's a D. But there's another case, 0, 0, 0, for the empty case as well. Therefore, we need to consider another column which is a representation of nothing. We have to have like another column. So in Python, when you are creating this one hot encoded variable, you will be asked whether you should create a new column for empty values. If you know your data set or your column is having empty values, you should. If not, if you already handled that before in your previous steps, and if you're guaranteed you will not have no value, so you can know that. Right, in this case you can have like this is a mistake, so you can have like one here. So D will fall under other, but the other column is not relevant. You can have like another category, and if you have it, then you have to have a D column, and the remaining columns, like other column, you can. For a machine learning model, you can only use these three. You don't need to feed all four columns. Okay, so now we are coming to an end of this discussion, which is like feature engineering. So we learned like a lot of things, how we can do the explorer, what we methods and techniques we can use for exploratory data analysis, and how we treat the missing values, and how we can treat the outliers, how they can be useful in terms of in our machine learning. Those techniques can be useful in our machine learning model, and why we are doing that. So we had a discussion on that. So now let's discuss about like feature engineering. So in the feature engineering, what we will be doing is we many things we do. Like few things I'm highlighting here. We are combining multiple features. So we have like two features. We can create interaction. So when one thing happen, another thing happens. So we can make some interaction. We can multiply two numeric values together, divide one feature by another one. We can make some interactions, right? And we can derive new features from existing features. For example, if you have a text column in your data set, you can extract certain keywords out of it, right? If you wanted to combine, like the combine multiple features, also a way of deriving new features. So whatever the features you have, it could be string, it could be numeric, it could be list of things in your feature. So you can derive new features, and then we can transform features, like the scaling, like we discussed, like how we can transform features. We can apply many different transforms: numeric to categorical, categorical columns to encoded columns, and we can do scaling, normalization, and then we can do standardization, different transformation we can do. And then after all, we have to decide which feature we should be using. For the feature selection also, we need to apply certain techniques, which feature I should be using, which feature I should not be using. All of these things I will have a separate discussion with the Python example, working throughout a machine learning problem, and going through a Jupyter notebook, and I will share it with you as well. And then we will get to know how we can do in a practical scenario all of these things. So I have like a couple of things to discuss. One is how we can do the feature selection. So in the feature selection, we can do in two different ways. So there are many ways, but here like I'm going to describe like in very basic ones: so the forward selection and backward elimination. In the forward selection, we can select feature by starting with the best feature. So how we can decide the best feature is your best feature? So we'll get to know more detail when we are doing the practical example. But the variable having the most predictive power, right? So in machine learning, as a side note, so we should start with the simplest model, the simplest number of variable combination, right? The simplest variable combination to begin with, because if you start with most complex model and 100 variables you throw into a model, probably your model training process will be lengthier. Probably you will settle into a solution which is not very optimal. Therefore, like it's a best practice to start small and simple. So we can start with one feature first. So we have to pick, okay, we have like 20 different features. So we will have that in our example to be discussed. So let's pick like one column. Say like if you wanted to predict something, if your feature is having age as a feature or a column, Let's start with age. So how age is related to like person's salary. So let's take that example. So we are trying to predict a salary of a person with a set of features, right? So let's pick the age and salary, and we will do all the analysis, and we found out, okay, the age is the most influential feature we can think of by the correlation coefficient with the age and the salary. We found out, okay, that is the highest with the other, when compared to other features with salary, right? We can think of, okay, it's having like a higher predictive power, and we choose that, and we evaluate the model, and then we add the next feature, like the next highest predictive feature into that. So then we are gradually adding feature by feature, and then trying to compare whether our model performance get increase or decrease. So if we think of a model performance is significantly decreased, so we can stop adding new features, and we can go to removing phase as well if you want, but in very high level we are adding features and checking the model, like training the model, check the performance, and if the performance improved, and add the next feature, like keep adding, right? There's a forward selection. In the backward elimination, we start with all features. If you have like 20 features, we throw all 20 into the model building process. We are training the model and evaluating the model, find out the performance, and then we can find out, okay, from the model training, we can in the training algorithms, we can get what is the most important feature for a model prediction, right? If you have 20 features, we can throw like one feature out because that was the least helpful feature to the model, so we drop it and then retrain, and then we do the same thing. We find out over the model performance, and we need to check whether performance increase or decrease. If it increase, so now we are going to eliminate the next least performing feature. Like that, we will eliminate a feature one by one, or like we can eliminate multiple features at a time as well, and then we are going to settle with the optimum feature list. So the forward and backward selection, you can interchange as well. So you are adding a feature, you are removing set of features, you are adding set of features and removing set of features. You can do depending on the occasion, or depending on the workload you are having. You probably need to do like a patches of features, or you have to do one by one if you really wanted to be very careful, depending on your time, and this is a matter of time and money, right? So training will take time. Training will use, if you are using a cloud based machine learning model building platform, so your time will cost you money. The computational resources will cost you money, and also the time you are spending with the problem or the project will cost you money. So therefore you need to decide, okay, what is the optimum method. But these are like two ways as a guideline you can use. Yeah, the feature selection strategy is also you can do based on missing values. So if you want to do forward selection or backward elimination, you can do that. The other ways you can do, even you can support this with the forward selection or backward elimination. You can remove features with based on the missing values. So if you're having, if you decide, okay, if a feature is having greater than 30% of the values are missing, so I'm simply going to throw that feature away, right? But in that case, I would suggest you to create a feature, new feature. So this is part of feature engineering, to indicate, okay, I'm not going to use that feature in model building, but you can create a binary column to indicate, okay, that feature is missing, and see whether that's going to improve your model performance. If it is not, you can simply drop, right? Sometimes like a missingness can also be an indicator of something, right? Therefore you can create a new feature to indicate we have a missing value, uh, but the original value you're not going to use. So you can decide to remove a feature, or like add a feature based on the variance. So you can simply remove a feature with a zero variation, right? With your target variable or y variable. So this is not definitely not going to help to learn, for your model to learn. Remove features with a low variation. You can make a zero variation. You can simply remove it. When it close to zero, you can decide a threshold. Okay, so variance is below this value, I'm not going to use it. you can make it a threshold. You can also use the correlation coefficient. So analyze correlation coefficient between features and those with the target variable. And you can keep a set of highly correlated variables with the target variable, and keep on having highest correlation coefficient with the target. So in some situations, you have to decide like which feature I should remove. So based on individual correlation coefficient, we found out okay, these two features are like highly correlated. Those are like kind of a, so if two features are highly correlated, they are, we can call it like collinear. So probably you can drop one. So if you drop one variable, or like if they are highly correlated, they also having a higher correlation with your y variable, you can decide okay, the highest the variable with highest correlation coefficient you can use, that other you can remove it if you really want to remove. If two variables are collinear, so not two, like you have three variables, so one can be represented by other two, will be, as we call it like collinear. Like the one simple example will be the example when we are converting categorical variable grade A, B, C, D into one hot encoded variable. The reason why I said I don't wanted to use all four columns A, B, C, D, one hot encoded columns, because if you have A, B, C columns can represent the D column without the D column, right? So that because A, B, C, and D columns, the one hot encoded columns, they are collinear. So you have to drop one. So that's why we don't need to use all. That's not a correlation, right? So I just give you like another side note. But the dropping the feature is, you can drop the feature with low correlation with the target. So without any doubt, so if you wanted to drop any feature based on correlation, if any feature is having very low correlation with the target, you can decide to drop. But there's a catch there. So if you still have like a slight correlation with the target, but even this variable combined with another variable is creating a high correlation or improving the correlation than the other variable how it correlated with the target, so then probably you have to decide whether I should keep it or not. That's a decision you need to make a very intuitive decision, right? Any of these things you cannot simply throw away just by looking at one value, or just because you like or not. So be careful. So probably you are dropping very important feature. Therefore, if you are dropping based on correlation, do like a thorough analysis. Based on variance, do a thorough analysis, right? Based on missing values, also incorporate a domain understanding or domain knowledge into the problem, or do it systematically. That is the end of our discussion on exploratory data analysis and feature engineering for machine learning. So we discuss in very high level of some concepts and some methods and techniques. Next will be we are doing a practical example, building a machine learning model using Python. So we will be using NumPy, scikit-learn libraries, and also pandas library to do this task, and we will be practicing these exploratory analysis methods we learned, and other techniques in order to prepare our data set for a machine learning model building process. And also we will go through a model building to help you understanding the model building steps as well. See you in the next one.